Hey everyone, thanks for joining us for the next session of our Spotlight on GitHub Advanced Security series, From Dependency to Deployment, the GitHub Supply Chain Security Journey. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand within 24 hours right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter for today. Carlin, thanks so much for joining us.
Thank you so much. I'm so excited to be here. My name is Carlin Cherry. I am a product manager at GitHub, specializing in GitHub Advanced Security. I'm really excited to be here today to share the GitHub supply chain security journey. When we ship projects, we're not only shipping our code, but of course, dependencies that we rely on as well. GitHub can help you secure your supply chain from understanding your dependencies to knowing about the vulnerabilities in them, and then, of course, remediating them. During this webinar, we'll talk about that. We'll talk about how GitHub Advanced Security helps you secure your software supply chain. We'll see some new features and enhancements in action, and I'll give some high-level implementation guidance as well for those looking to get started. I'll be giving a couple of demos throughout the presentation as well. We're going to start understanding the supply chain security challenge. What is software supply chain? Then we'll talk about some of GitHub's solutions to help secure your software supply chain. At a high level, we'll cover the dependency graph, dependency review, Dependabot, including Dependabot Alerts, Dependabot pull requests, and we'll also discuss securing builds with artifact attestations. So let's start talking about what is supply chain security. I have a question here. It's a poll. How many dependencies do you think are in your typical application? Drop your answer in the comments in the chat. And while you're doing that and thinking about that, I'm going to give a little bit of color to this question. When you're developing a software project, you are most likely depending on other software, things like open source libraries, frameworks, maybe other tools. These dependencies, the things that you rely on when you're developing, and in turn, their dependencies are what's known as your software supply chain. And if one of those dependencies has a weakness, your project can be disrupted in what's known as a supply chain attack. So I asked this question in the poll, how many dependencies do you think are used in a typical web application? And this is actually a little bit of a trick question because pinpointing the number of dependencies that are used in a typical, I'm using quotes here, typical application is quite difficult. It can depend on a lot of factors. Generally, though, the average number of dependencies in an application is high. It's on the number of hundreds to thousands. So if you were thinking about an order of magnitude of hundreds or thousands, you're pretty much on par. Modern web applications, especially those built with JavaScript and particularly NPM, are known for having a vast number of small reusable packages, which leads to a large number of dependencies. It's also a growing trend. So not only do most modern applications have hundreds and thousands of dependencies, but the number of dependencies is increasing over time. There's a number of different data sources that kind of indicate this, but one I pulled for this presentation suggested a 200% increase in the number of third-party dependencies used in a typical application since 2020. So most applications have a lot of dependencies. It's the number of dependencies that are used is growing over time. And finally, almost all applications use dependencies. Something depending on the source that you read, but some estimates are on the order of magnitude between 98% to 100% of applications audited use open source. Not only do they use open source, but the components in open source make up over 75% of the code in your typical application. So I ask this question and kind of give some of this context just to say that, Your supply chain is important, and using dependencies, open source dependencies, is a really big deal in most contexts. So yeah, you're using open source dependencies in projects, and that's great. That's because using open source dependencies allows developers to leverage these kind of community vetted and community created solutions to software engineering problems that everyone faces. So it accelerates development because developers don't have to reinvent the wheel every single time. They want to use a pattern that is frequently used by other developers too. However, there is no such thing as free lunch. Using an open source dependency can come with some business risk. If one of your dependencies, these open source dependencies that you're using in your application, has what's known as a security weakness or a bug, a malicious actor could exploit this vulnerability to do something that will disrupt your project. So this type of threat is called a supply chain attack. Having a vulnerable dependency in your supply chain can compromise the security of your own project and put your users at risk too. I have on the slide a number of headlines where we have seen this kind of supply chain attack play out. You might be familiar with some of these names, some like SolarWinds, Log4j, XZUtils, and the latest software supply chain threats involving generative AI, which can be used to write code. Really, though, these are just a few examples. It's just the tip of the iceberg, honestly. And the list of high-profile software supply chain incidents is long and helps underscore the potentially far-reaching ripple effects and severe consequences of compromised software dependencies. So we have an understanding now of supply chain, the software supply chain, what it is. It's, a small slice of that is using these open source dependencies and the implications thereof, not just on software development. You're increasing the speed at which a software developer can, create code and create an application, but also comes with some business risk in the form of potentially a supply chain security attack. Let's take a look now at how GitHub can help everyone from open source communities to Fortune 500 to Fortune 5 enterprises secure their software supply chains. When we ship projects, we're not only shipping our code, but also the dependencies that we rely on. So GitHub can help you secure your supply chain, and that starts with the dependency graph. Here on the screen, you're looking at the dependency graph UI in GitHub. A dependency graph is a list of the packages that make up a project. Each of these entries in the dependency graph will show a dependency version number, ecosystem, license, and whether it's a direct or transitive dependency. An important differentiation here, a direct dependency is a package or library that your project explicitly declares and imports in its config file. So you can think of that like a package.json, requirements.txt, pom.xml, whatever your preferred ecosystem and language is, something that your project directly relies on. Whereas a transitive dependency is a package that your project doesn't directly use, but that is required by one of your direct dependencies. So you can quickly see how your dependency graph gets bigger and bigger and bigger depending on the number of direct dependencies that you use and the number of transitive dependencies that are used by those direct dependencies. From this UI, you can also export a software bill of materials or an SBOM, which is a standardized data format that lists your dependencies. This is most frequently used as part of a compliance requirement, perhaps for an enterprise, or part of a regulatory requirement, so that you or a government agency can know exactly what dependencies make up your particular application. The dependency review action is also something that can help you understand dependency changes and both their security and licensing impact, and this takes place on every single pull request. The dependency review action can kind of be configured to act like a unit or integration test that blocks PRs from merging if certain policy conditions aren't met. Here you can see a workflow file for a dependency review action. You can see here that I've configured a severity threshold for a detected vulnerability. Here I've said anything with any dependency that has a high severity security alert associated with that dependency will be blocked and disallowed from being merged into the code by this workflow. In addition to severity levels, you can also explicitly allow or disallow certain license types, which ensures compliance with your organization's policies and license requirements. So in this particular workflow file, I've configured it to disallow GPL or copyleft licenses, in addition to some others. The dependency review action can help you reduce the likelihood of risky dependencies making it into production. I have a QR code here that you can scan if you'd like to learn more about the dependency graph. We're also going to make sure to include the links to all of the information if you're interested in learning more about any aspect of GitHub Advanced Security that I'm talking about today. So, if you're interested in learning more about the dependency graph, we'll make sure to also include a link to the docs if you're not able to scan the QR code at this time. Overall, you can think of the dependency graph as GitHub's kind of brain that's powering our supply chain security. The dependency graph can parse a manifest file and know about the direct and transitive dependencies that are used in your application. And what does that allow for? That allows not just for us to be able to detect a vulnerability, but also for you to meet certain compliance regulatory requirements depending on the dependencies that are allowed or disallowed in your organization or by your particular governing body. So we've gone over the dependency graph. Now I'd like to switch to a demo for Dependabot Alerts and Updates. Right now, we're looking at a demo organization within GitHub, and you're on the Dependabot Alerts page. So this is Octodemo, the organization, security tab, and we've selected Dependabot Alerts here. Dependabot Alerts leverage the dependency graph to proactively notify you when your repository has a vulnerable dependency. You can get a Dependabot alert by when you have a change in your dependency graph, i.e. you introduce a new dependency into your application or to your environment, or new advisories are added to the GitHub advisory database. So let's take a little sidebar here and talk about the advisory database. I'm not being self-aggrandizing here when I say that the GitHub advisory database is one of the top vulnerability databases in the world. It truly is. It's a security vulnerability database that includes CVEs, or common vulnerability exploitations, and GitHub-originated security advisories from the world of open source. It's very comprehensive. You can see there's 22,000 open reviewed security findings here in the advisory database. So what does the advisory database do? It detects when there's a vulnerability, we know about it, and then we kind of trickle that down into Dependabot. So here you can see number of Dependabot alerts, each of which originates from a CVE from the advisory database. Alerts include a link to the affected file in the project, information about a fixed version, and whether the dependency is direct or transitive. So here you can see, I'm just going to open a random Dependabot alert in this organization. And you can see that it contains a lot of interesting metadata that might be relevant to you. Like I mentioned, whether or not this was direct or transitive. We also have some other information, including CVSS, which is severity. Here you can see that this particular alert is critical. We can also look at EPSS, which is shorthand for exploitation likelihood. The likelihood that this particular vulnerability is likely to be exploited in the next 30 days. And there's other prioritization elements that exist here that can help you understand risk and ultimately prioritize remediation efforts of certain alerts over others. If you are interested in learning more about prioritization, I'd encourage you to check out the Reactor series about using Dependabot to prioritize your security findings. We're going to drop a link to that here as well, to the Reactor series that I gave a couple of weeks ago about prioritization with Dependabot. Another thing that you can do with GitHub Advanced Security is set up custom rules, systematic things at the organization level that allow you to triage your alerts based on your organization's risk tolerances and preferences. Let's take a look at that in action. We can go to the settings page, select Advanced Security, and select Dependabot rules. Here, something that you can do is create a new rule, call it whatever you want, and you can dismiss alerts based on certain criteria. So let's say that your organization doesn't really mind low severity alerts. And let's say that, they want, EPSS or the exploitation likelihood to be, whatever risk preference you have. So less likely to be exploited, low severity. You can use GitHub Advanced Security here to create this type of rule, which will automatically perform an action to triage Dependabot alerts depending on your risk tolerances, your preferences. This is just one way that GitHub Advanced Security can help you customize your rules, and depending on what you want to do here, can help you, triage your findings from Dependabot. All right, we chatted a little bit about Dependabot alerts. So these are really the findings that Dependabot has. Let's chat a little bit about Dependabot pull requests now. Dependabot can also make sure that found means fixed by automatically creating a PR to help update dependencies that have a security vulnerability. Let's take a look at one of those right now. I'm just going to look at, kind of a random Dependabot alert that has already been solved. You can see that this particular Dependabot alert was due to this particular vulnerability in the package next. So this is a JavaScript NPM vulnerability. And here Dependabot opened a pull request to resolve this alert, or, in other words, fix the vulnerable dependency for you. It says what it did. It bumped this package from this version to the next version. And so really what we're doing here is ensuring that found means fixed, because Dependabot helped open this pull request to resolve a particular vulnerability that it had identified. In addition to security updates, those pull requests that originate from a particular security advisory, Dependabot version updates can also help keep your dependencies up to date, even if they don't have a known vulnerability. You can think of this as good hygiene. Just whenever there's an update from a package maintainer that has the latest version of a particular package or dependency, you can just get that up to date in whatever form that you want to. You can also customize Dependabot in a lot of ways. There's a dependabot.yaml file that you can use to do things like control the frequency and timing of Dependabot checks. You can also use grouped updates to organize pull requests with multiple dependencies. You can target specific package ecosystems, and you can choose the Simver level of updates, whether patch, minor, major, to suit your needs, and so on. These are just a couple of examples of ways that you can customize Dependabot according to your preferences, your schedules. You can customize by ecosystem, by repository. You can kind of do a lot of customization with Dependabot here to really get it to do exactly what you want it to do. And being pull requests, of course, any actions will run up against the PR that Dependabot creates. That includes any tests that you have set up to help verify that the updates won't break your project. If you're interested in learning more about Dependabot, whether Dependabot alerts, Dependabot pull requests, and customizations that you can create with Dependabot, here's a QR code that will take you to our documentation. You can also select the link in the materials following this presentation. All right. Supply chain security doesn't just stop at dependencies. So it doesn't stop at Dependabot. It doesn't stop at the dependency graph. Sometimes the build process itself can be compromised. So we're going to talk a little bit about the build process piece of the software supply chain and how GitHub can help you start to make steps to secure your build through artifact attestations. Artifact attestations provide cryptographic proof of build integrity. and they enable you to increase the supply chain security of your builds by establishing where and how your software was built. So far, in terms of supply chain security, we've been really focused on your source code. We've been focused on your dependency graph. We've been focused on your Dependabot alerts and Dependabot pull requests, and that all happens in your repository, right? So what happens when you take that code from a repository and deploy it? That's what we're going to talk about next. You can create an unfalsifiable provenance and integrity guarantees for the software that you build. And in turn, the people who consume your software can verify where and how your software was built. Quick detour, you might be wondering, what exactly is an attestation? And an attestation is basically a cryptographically signed statement of fact by some trusted actor about a specific subject. So in the case of artifact attestations, of course, the actor is GitHub, and the subject is some piece of software made during a GitHub Actions workflow. Here's an example of what this starts to look like in the GitHub UI. A provenance attestation binds something built on Actions to the source code and build instructions that originated it. We've said it before, we'll say it again. When you generate an artifact attestation with your software, you can create this signed claim that establishes your build's provenance and includes some of the following information. Things like a link to the workflow associated with the artifact, the repo, org, environment, commit SHA, and triggering event for the artifact. Could include other information like the OIDC token used to establish the provenance. You can also generate artifact attestations that include the associated SBOM, or software bill of materials. Associating your build with a list of the open source dependencies used in them helps provide transparency and enables consumers to comply with data protection standards. Securing the build process with artifact attestations is crucial because even if your dependencies are secure, even if you have done the due diligence of enabling the dependency graph and Dependabot, and even if your dependencies themselves are secure, attackers can target your build pipeline to inject malicious code or tamper with your software before it's been released. Artifact attestations provide this cryptographic proof of where, how, and by whom your software is built, which helps give you confidence in the integrity and provenance of every release. Regulatory requirements around software supply chain security have increased over time, and having this verifiable and transparent build record is not only best practice, but it's also rapidly becoming essential for compliance, consumer trust, and risk mitigation. I have a couple of regulatory and compliance benefits that you get from doing artifact attestation. Some of those are in the EU, so like the EU Cyber Resilience Act. Other ones are like the Executive Order 14028. There's also industry standards that you get, like NIST and CISA guidance compliance. And artifact attestations are also, starting to get you closer to a SALSA build level that you might be interested in. All this is to say that our journey securing builds with artifact attestations is just beginning. It's really the bleeding edge here, and you can expect to see more to come from GitHub Advanced Security on securing builds and using the dependency information in those deployed artifacts to help you prioritize your source code remediation efforts with Dependabot. To learn more about artifact attestations and get started increasing the supply chain security of your builds by establishing where and how your software was built, you can scan this code. Again, we'll have the link in the materials from this presentation as well. So if you're not able to scan, don't worry. This isn't your only opportunity to learn about artifact attestations. With that, I would like to thank you so much for your time. If you have any questions about GitHub Advanced Security in terms of securing your supply chain from dependency to deployment, please feel free to drop that in the chat. If you have any other questions about other parts of GitHub Advanced Security as it applies to the supply chain, please feel free to drop it in the chat, or you can also message me or find me after the presentation as well. Awesome. Thank you so much, everyone, for your time. It was really wonderful to be here to share GitHub Advanced Security and the supply chain journey. Thank you again.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.